preparing it. So
And there. Yep, it's up now.
we're live. Yay. I always wait for my confirmation on my end.
Just to be
Um,
safe.
yeah, just to be safe,
Very weird that I get it first, or that the stream gets it first, I guess.
It is weird. And then it's funny because on my end it says video unavailable. I'm like, okay. It says this video is private. Like, why? Oh,
Yep,
why?
there we are.
Okay. So as long
All right.
as it is
Go ahead and
showing
mute
up on
this.
end, we are good. And I'm gonna close this.
Oh, it does say video is private.
Okay. Well, let me see if I can fix that. Does that make
That's a new one.
yeah, that's a new one. So while I'm gonna see if I can fix that really quick. Um,
Oh, 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 oh.
what's that?
Okay. As of now, just saying that private thing, now it's showing up.
Okay, good. All right. So I
So
didn't.
we're talking about it right now.
Okay, good. All right, yay. That's all I needed to know. So we're live. Hello, anybody who may be watching out there. Welcome to our August, what day is it? 25th?
25th.
Yeah, 25th stream. So today we're going to talk about the KP index and the August 11th and 12th event, which were that was um recommended or not recommended, but asked about. But we figured it was a good tie-in to the KP index and its flaws and what it can be used for. So that's the gist of this whole talk today. So welcome aboard and welcome to my co-host, Christian,
Hello, Justin.
partner in crime here. So we're going to start off with the August 12th and August 11th, 12th event. So
We do have technically a title now.
yeah, we do. Oh yeah, that's right. I forgot. We we spent the last week talking about what should we call this? Because Space Weather Weekly was kind of like, I don't know. It was it was a placeholder. So we settled on Space Weather Unplugged because, well, it's not like we're a bunch of professionals here. Um,
I mean, this is literally like the definition of unplugged, right?
yeah.
What it feels
So
like, at least.
yeah, it feels very unpluggish. So we're gonna roll with it. Actually, should I start off with our little I have my little
Let's
disclaimer.
go ahead. Yep, yep.
Oh, I put up this. I wrote it. I'm trying to be more. Speaking of more professional, trying to be. Let's write like some notes to take here. So let's see, where is it? So these are my notes to beginners who might be watching this. And yeah, hold on. I thought I had it up. So during an extended event like we had on August 11th and 12th, you can use the KP index. You can. I'm not gonna sit here and lie that you can't. Because it's a 3 hour average, but if you have an event that's going 18 hours or more, it's gonna have an elevated KP, and that's fine. That's why a lot of people will say that they saw Aurora and they're like, the KP was X amount, and sure, it was. Um, where it becomes a problem is when you get short-lived events or we're dealing with things like background everyday Aurora. The KP will never show those substorms. It just won't. It gets smeared into the data. So that's kind of where I wanted to go with this conversation is that for the beginners, and it's funny because we've been harping on this that you don't want to do it, you don't want to do that, but I've gotten feedback from a number of people that, I shouldn't poop on it all the time. Um, but for
So this is our
extended,
one praise.
yeah, I was, reeling back a little bit. Um, sure, sure, use it. But but just know that it's at our disdain because it just misses so much, and we're gonna go into it as to why. And hopefully, as you start your Aurora chasing adventure, you will start to realize this and want to use the other tools that are available out there now, including the Glendale app, which we harp on every week because it's the best thing out there.
Thank you, Andy.
Yeah, thank you. And then I will also note that all of these indices, AE, DST, KP, are all global indices. So that in and of itself is a problem because a lot of these are heavily European biased because that's where a lot of the stations are or historically were. So yeah, the deflection might be in Europe, but we're not going to see that over here and vice versa. So that in itself is a problem. So anyway, back to our regular scheduled program. I wanted to put that disclaimer out there. And I can't wait. I can't wait for the comments on this because we've been harping on it so hard about the KP index. Yeah, anyway. So Christian, take it over.
Sure. So yes, we actually have something that we're praising it for, or at least giving it some credit. And it's really all about the precision. I mean, it's how much precision do you want in your Aurora searching? Do you actually want to know minute by minute what's going on and what your chances are, or are you just looking for a general overview? Really, that's the kind of idea as to what tools you need to be using. For now, though, we're going to go ahead and jump into the August 11th and 12th event, which actually, now that I just thought about it, the event that came afterwards, that was G4 Storm, right? Like the 17th, 18th, something like that.
Yeah,
That was a short-lived event. That one was one that I believe only had one 3-hour KP session where the KP was high. I
right.
will double check on that, but that's a good example compared to this one, which was a little more sustained. So let's take a
Yeah,
look.
this one I believe lasted about 18 hours, if not a little bit more overall.
That
Like
sounds about right.
just looking at all the data put together.
All right, this is specifically for anyone that wanted to know kind of sources. This wasn't really a very noticeable one if we're looking at the actual sun itself. I have just the AIA 171 channel up. This looks at the corona of the sun and the hotter plasma that usually forms with coronal loops and the flares. At this point, this is in differential imaging, so it's a little easier to see changes from frame to frame. There are, I think, 2 eclipse periods in here, though, unfortunately. The first eclipse period almost exactly hits right when the eruption shows up. And then you start seeing some open field lines just right after that. This causes a CME to be seen going out to Lasco C2, C3. Actually, I guess we can just play this through because this helps a little more. One, and then there's a second. So there's 2 specifically here that I'm looking at. Technically, there's 3. I don't think this third one had any relevance to Earth, though. I know that in the CME scoreboard, one of the reports shows that it very well could have. And honestly, the data is messy anyway, so it's hard to tell. But I'm seeing 2 specific CMEs that I'm pretty sure are interacting here. But the idea is they come from 2 eruptions from this group, which the second one is quite a bit more obvious if we're going in further.
Mm-hmm.
I mean, yeah, it's really
I
hard to
see
miss
it.
that one,
Yeah.
which also was almost immediately after the first one, about 10 hours, we'll say, which in sun terms is really not that long. So then going back to the data itself, this is from August 9th till August, I think I put into the 14th basically, which is around when this show really started to die down. First thing to note, we had a small impulse, about 12 UT on the 10th, and this was considered the first one, that little thin wispy CME. Really did nothing, and we all just kind of laughed and just went about our day because it was really nothing.
We did.
Then, literally, in fact, I might have taken a nap after this point, to be quite honest. And then at some point, we get some buildup with the IMF. The IMF starts building as what I believe, this is my thoughts on it, the sheath coming up from the second one that was pushing into the first CME. So as we're starting to see that increase, there was then a pretty significant change in magnetic field status around 5:30, a little before that UT. We see BZ jump completely south and the IMF start jumping up even further, where we start seeing 20 nanotesla. And I don't know if anyone else here has been a long-term chaser, but 20 is generally good for G3, G4 storm levels, depending on the length and how good it gets. So that's usually a good number that most of the people in the US and Canada would want to be aware of for the sake of Aurora.
I do think we called this out too on the that one stream that we did during that day. It was like, oh yeah, and it did hit G3. And then but we didn't realize that it was gonna escalate later.
Yeah, I definitely called it at least a G3, but I was not into G4. And then hello everybody that is watching. I see we've got quite a few bits in the chat right now already.
Okay, good. We actually have the live chat up this time.
So we're actually looking at it. If you have any questions or anything, you can pop in. Not to say we'll definitely get to that, but it's at least there.
We're trying to be more professional.
But still unplugged. Can't keep that straight enough. Um, let's see. So we're looking at the first CME train. Yes. So again, this is the 10th, 11th, and 12th show specifically that was requested. There was a show after that with the X Flare. We're not looking at that one mostly because no one called it into question at this point. But really, what got this going after we see the first impulse, there was a pretty heavy period from about 2100 until 2300 of the BZ just being as south as it gets. Now, if we want to go as in depth as flux ropes and looking at kind of maybe how many CMEs were involved here, I want to say there was probably 2 involved, which would make sense. There's a couple different starting points where you could see either an east-southwest, which we have about right here, to 8 UT on the 12th, roughly. We start seeing a negative BZ and a pretty constant one at that in the minus
Mhm.
13, 16, 18s. We see the field primarily hit south, and then it generally goes west. But then we get an increase in BZ that goes into the north, which I want to say around here, 1818, we see some weird field nonsense going on, and then we start seeing what looks more like a southwest north. So it, we're talking about two complex CME interactions. There's a decent chance that it may not even be either of these. It might just be coincidence. I'm going to say no based on the temperature. I'm pretty sure this is what we're looking at. But really, the main period of what we got as far as the high activity was from this long period of negative BZ that took place from about 2 UT on the 12th, which would have been overnight on the 11th in the US, until the next day. So I believe that Australia and Tasmania got some of this as well. So it was pretty good, ultimately. We saw quite a bit of info come out of it. As far as DST crossed down to about minus 200 nanotesla, which I want to say was third now. This took
Yeah.
place pretty quickly. It
It
took over March of 2024, if I'm not, or April of 2024 it took over, I believe.
yeah,
All right,
it was a
2023.
it was a decent hit.
And
So
then, of
there's
course, we
that.
see it starts recovering. So there's a couple different periods here where it goes about one minus 150, and then it hits the minus 200 at some point. That's when we start seeing the negative BZ for the prolonged period at least. And then it's just recovered since then, not really much to look at. Looking at the KP index, what we saw two periods of geomagnetic storming, technically high geomagnetic storming. This one is where it finally hit G4 level from the 12 to 1500 level, and then it went down to probably 7.6 is my looks of it, which is technically an 8 minus. Oh, it's down here.
Yeah.
Convenient. So an 8 minus on the KP scale. But it was elevated for most of that day. This was a fairly elongated event, once again, because we had some pretty heavy negative BZ periods here, which was already following a disrupted period in the IMF. Once the IMF value gets to 18, 19 nanotesla, we're going to expect to see geomagnetic storming regardless of the BZ orientation usually. But it's always nice when the negative comes in and we can count on the long term to actually work. So we had those couple negative periods and then the long term period to influence. So we see more of two spikes rather than anything else. This was the HP30. This is the 30-minute increment in them all, which you try to compare the two, which I like looking at two. Oh, they're on two different pages, of
I
course.
know.
Yeah, we
Wow.
tried. Can only go so far. From
Yeah.
12 to 1500, that's where we saw the G4 levels. From 12 to 1500 here, there were multiple sevens, eights, and even a nine. But then you average those together, and we're getting the 8 level, and then it just kind of decreases from there. We see a period of 4 here and there. But the main chunk is this was the negative chunk where it first went negative for a very short time, and then the extended storm that happened with the long negative BZ.
And don't worry, we're gonna go into these different indices.
Yeah, this is relevant at least as far as the storm, but there's going to be an explanation coming next. Of course, we have the
Yep.
AE index as well,
Should be
which
further
is
down.
further down. There we go. This is
And
for
you
the 12th. We had values hit of about, well, a couple different times. 1700 nanotesla. We even had it peak at about 2000 at 11 UT, roughly.
yeah, and you
The
can see
lower
those multiple periods of substorms,
one, two, three, four, five.
which is why like you have like the activity increase and it goes away, increase, go away. So yeah, it was an
And I guess
extended event.
I would assume anyone that saw this, let's say in the northern tier of the US, maybe a little bit south, would be able to attest to seeing it going back and forth and back and forth. I will say I chose to sleep that day, which I do regret.
Good job.
Pat on the back for me in that case, or slap in the face for me. I'm going to go with that one instead. Of course, we like the Glendale app, the Substorm Tracker, because it is probably the most efficient way to view all of this. And I don't even know probably belongs in that sentence. Let's be honest.
Mhm.
But you can see clearly that we've got very deep levels after, well, right after August 11th. So as soon as August 12th hit, that's when we start seeing the dive. And then several different opportunities. These are substorms on top of substorms at this point, but we had clearly one, two, three, especially three bigger areas during that day. And then as the day went on, there were also several other occasions that were separated by 20, 30 minutes. And then it looks like a period of calming until what, 2 hours later, and then it hit again.
Yeah.
So now, just as Mary Beth's going to explain this, I'm just going to briefly touch on it. Notice that compared to the KP levels, this is showing these spikes individual times when the aurora is going to be flaring up.
And
If
if
you
and
want
if you
precision,
yeah, if you want precision, this is what you want. And if you
this is where it's at.
compare this substorm tracker to image timestamps that you might have got from that night, I guarantee you're gonna find it within the substorm tracker here.
Somewhere in those spikes. Yeah, fully agreed. And that's all I had for at least the August 11th and 12th event. Let's see. It looks like no further questions on that part, just to
Okay,
make
good.
sure. But I do want to mention that if you've seen it already, there's a CME on the way. The quotations were for on the way, not necessarily for CME. There was a CME launched a few days ago. The certainty in it is very low. In fact, looking at the Huxt forecast, it's barely giving it a 34% chance, with speeds barely bumping above 400 kilometers per second. I, to be honest, would not count on much. The CME scoreboard did model it as well in quite a bit of different areas where there were further models, and everyone is low confidence at this point. So if it does arrive, don't expect too much, but the general expectation is not much.
Eh, meh.
Yeah, that seems to be anytime I have to give a report for what's coming up, that seems to be how I have to give it now. Kind of started to get offended here with solar wind, but
But it's all good. But
yeah,
yeah, I
I'll
mean,
protest that another day.
we wanted to mention that because, well, it's space weather, so we wanted to mention, hey, there is something that's been modeled, so here you go. So
Exactly.
on that note,
It's there.
but that's why so some of the comments we got back was like that it was an all night a thing, and it was. Um, but the to the point on what sparked this KP versus using substorm trackers and stuff like that to follow along is there were periods of very intense activity versus periods that weren't. And but when you put it all over the whole night, yeah, it would go from dawn until dusk. It's just if how badly you want to chase substorms is really where all this is going to come in. So let's talk about our friend the KP index, shall we? All right.
That's the second compliment we've given it, just in case anyone's keeping track. Friend.
Yes, friend. All right, let me make sure I have my Google Docs up here. Can you see the Google Doc?
Yes.
Okay, good. Because I have it on the other screen, so I'm going to try to read off of this. So we'll start at the very tippy top because this is my everything you ever wanted to know about the KP index. I call it a memoir because it's my memoir to what got me started in this and got what has just about everybody that gets started in chasing these things. Um, and what it is, why it's there, why we use it, and then why we want to move away from using it. So the first thing we're going to talk about is how I'm trying to figure out how to phrase this. So, because like the KP index, AE index, and DST, we're going to go over these three indices, but they're tied to specific areas in the magnetosphere. And I can't really go into that without explaining how they got these numbers. And it has something to do with something called an L shell, which is, if you think of it like Earth's magnetosphere as an onion, you can peel back these layers. And the outermost layer is going to be L5 and above. That's the kind of maps to the magnetopause. And that's going to be the A index. It maps to the stuff way out there, which is why it is the first to get deflected. So as the solar wind bombards in, it peels these layers away. And the further it peels away, the more these different indices are going to get show deflection. So that being said, L5 is AE index. This map right here that you can see kind of shows where they are, and we'll get into when I show where these stations are, you'll see exactly why they are where they are. It's because of these different L shell locations. So let's see here. We'll start with the E index, and you see this chain, the little red dots. They're all within that Aurora oval, so they're all within that L5 or above location in the configuration.
Are we able to zoom in a tiny bit on the photos?
Let me see. Let me see. Oh, oh, that's not what I wanted to do at all. So let's get rid of that. Um, can we zoom in? Can we
Yeah,
zoom
that would work. You can kind of tell from the screen, but it's
in? Yeah.
it's pretty small otherwise.
There should be, it's kind of funny because there should be like a plus or minus, but for some reason, when I look for it, I can't find it.
No, I
Uh,
don't see it either.
come on. Come on, Google. Uh, Fudge sickles. Oh, wait, here it is. Is that
Ah, perfect, perfect. Yep,
better? Okay.
much better. Now you can see the individual lines and latitudes. Okay,
It just took me a
great.
second. Sorry. All right. So yeah, I mean, like we'll back up to L shell here because you can see L5, L4, L3. So like this maps it out. And this kind of shows and what it is, and this is what I forgot to mention. So the numbers mean distance. So it's how many Earth radii out something is. And we'll back the bus up a little bit. So the DST is going to be located near the equator, which is going to be L 1.5 to 2, which is the heart of the magnetosphere. That's where it's strongest. So it's going to see the least amount of deflection unless something big's going on. The ring current is located between 3 to 5. So this is actually what the KP is sort of monitoring is ring current and to some extent AE. It kind of smears those two together to give you a better average of what's going on, which is better. It's just more helpful for anybody watching geomagnetic activity is having that average between them. And then of course L5 and out is going to be the magnetopause, basically. Or yeah, upper lower envelopes, I think we went over that last week, but we'll go over it again. But anyway, that's what these are. It's Earth radii out. So it's the distance out, basically. So now we're back to this. So now you can see the chain
There we
of
go. Yeah.
magnetometers that are in the AE index, and they're all in that northern
High
tier.
latitudes.
There's none in the southern hemisphere, and that's really because we don't have a good way of getting them down there. I mean,
Look at all
most
the
of
land
us,
options you have.
yeah, you only have Antarctica really, which is really hard to get to, just in general, and then water. So it's just way easier to put these stations because you have to maintain them. So you can't just like put them there and then not have a way to maintain them. So it is very heavily biased to the north. And then I wrote a little blurb about it. Actually, this was for AE. So what's neat about AE index is it is a minute by minute interval. So it is near real time, which is pretty cool, which is why us chasers like to use it as a visual because it's the closest thing we got to real time other than our current substorm tracker that Andy has developed for us. Um,
Literally.
but it gets overwhelmed pretty easily, which is something we discussed in the last live stream about like these larger events, it just gets overwhelmed. Um, so that's another topic. So DST, that's located at those real low L shells. So it's the heart of magnetosphere. And these are comprised of 4 stations. These 2, these 4, and they're pretty close to the equator. These are done at 1 hour intervals. There actually is a higher cadence one available called the SIM-H. And it is a little bit higher cadence than an hour. But this is something we're more concerned with after the effect, because we like to see how strong a storm was. And you can look at the DST and get a good idea, like we just did for this August event. Now that it's all been finalized, and you can see that it was actually a pretty significant event by using DST.
Yeah.
Then our last one is our friends, the KP. This is our middle latitude stations, 44 to 60 degrees, monitors the L shell 3 to 5. And it's kind of our little sweet spot because, as I said earlier, it catches the ring current involvement and the AE involvement. So it kind of gives us a good general idea of what's going on. It is a derived index. So it's on a 3-hour delay and it's derived after taking the quiet systems out because there is, believe it or not, daily solar issues and lunar variance on magnetic readings. So you have to take that out in order to get the true picture of what's going on with the index. So that is subtracted out of the H component of the magnetometer stuff, which is something we touched on a little bit last week, is that's kind of the magnetometer data that you look at. It's mostly the H component because that's kind of where the KP is derived from. The other ones you can learn some stuff from too, which will be a topic for another day because we could go on forever about magnetometer data. The key
So
point here is it's a 3-hour derived index. So we'll get back to that. A little bit of history on it. Julius Bartels was the one who standardized it, basically. It's a quasi-logarithmic scale from 1 or in steps of 1 from 0 to 9. The other problem with that is it is capped off at 9. So if you have events that are really, really big, all we do is 9.
what's bigger, a 9 or a 9?
Yeah, so that is one of the other problems with the KP index, but it has a very high historical context, so we do use it. The other thing is it is biased towards the northern hemisphere and Europe in general, which is it's unfortunate for our friends out in down under because We do have a very northern bias on it, and that's why it's really important to get a lot of the stuff more on the local area. Because what happens over in Europe may or not be what's happening over here. And then you're going to get this skewed data because of that. Um, so that's the little bit of history on it. There's a cool thing you could look up called Bartel's music. I might bring that back up maybe if we got some time because it's a really good because this whole index was really derived for climatology use to give you a picture of what went on geomagnetically over a period of time. And it does a great job doing that. You can look back in time and like, oh yeah, there was activity this day, this day, and this day. It went on for X amount of days. This year had more activity than others. And it's really great for that. It becomes problematic when you're trying to use it to real-time chase. So, but we have some options now. And that's where we brought in this HP 30 index earlier. And this is a newer data product, HP 30, HP 60, and the numbers you see there are for the cadence. 30 is every 30 minutes, 60 is every 60 minutes. That's a lot better than 3 hours.
Right.
But, and as you can see when we had, oh, we'll bring it back up here. This is your 3 hour average, but look at the 30 and just look at the difference between these two. Like it picked up all these sevens and even some eights and even a nine in there that was not shown at all in the 3 hour index. So it's a step in the right direction, absolutely. However, it's still going to miss substorms because that's just it's still not good enough. But it's closer. And if you want to stick with the whole KP world, I would recommend getting more on board with the HP 30 and 60 versus the standardized 3 hour index. Because of that reason. It's a higher cadence. So that was kind of what I wanted to say on that. Let me see, because now we wanted to kind of compare why this is important, which I put together a little graph on the bottom here. I might have to zoom back out. So let me zoom back out.
So ultimately, to summarize that at least, do you want to see the aurora once at some point through the night, or do you want to know how many times it's going to be out during the night and see those opportunities? Because that's kind of the
Yeah,
differences of what we're talking about.
this is really the difference. And I tried to align these four different data products in a way where it was time stamped, like with the UT. The problem with the Glendale Storm Tracker is it was split into the 2 days. So I can only get part of it. So I had to move it over quite a bit. And then the scale changed because the one substorm was so much stronger than the other ones. So the scale changed a little bit and I couldn't align it. So that's the reason why these are moved over quite a bit versus this one. But the interesting thing note here is if you look at the substorm tracker and that big dip, the AE index did a really good job following that. However, look at the two KP indices, specifically the 3 hour one. It is way off.
Quite a bit. Difference
It
between almost G5 levels and G3.
yeah. Yeah, which is I don't know if you're ever out when you're chasing Aurora, like this has happened to me several times now. I'll get the alert for a G3 or G4 storm and I'm like, well, that good part already happened. And that's exactly what happens because this is on such a delay that it's going to miss this type of information. And that's kind of our takeaway with the KP is that sure in longer tracked events is if you go out and it's still a G5 you're going to see something especially in the northern tier of the US, but let's say you're in Chicago where you have the land of all the light pollution that there is. People were able to see it downtown Chicago, and I guarantee you the timestamp is this right here. This dip right here. If they were following the KP, they would have totally missed that completely because the KP would have been it would just been too late. So that is the big difference between these indices and why like we will harp on it over and over again that it's just not helpful in real-time situations because you are going to miss these types of details completely. The AE index is pretty close because you see it actually tracks pretty darn well with it. It's still on a delay though, so it's still on a one minute delay. So if you have like your regular background data or background Aurora that's happening, and you see something happen and it doesn't show up in the index, there is still a time delay there, even though it's pretty close. So I'm not entirely sure, and I know we got this question last time about how Andy gets this information because it's proprietary to him. So he's not willing to divulge that information. But whatever it is, it's definitely by far the best thing that we have for Aurora chasing. So that's why we will always talk about, if you're into this, just download this app. Don't really worry about all these other ones. The Space Weather Live one is great if you're looking for just a snapshot of the
Generalized
current
data.
the data at
Yeah,
L1. Because it has a really nice interface. Like I really like the graphical interface of it versus like going to the source over at Swipsy. Um, so it's great for that. But if you're
agreed.
looking to substorm chase, you really want the Glendale app. You just do. And that's my little stint of that. I think I had some other thing. Oh yeah, speaking of apps, because that actually, I think we're gonna do a series on going over different apps. That's in our to-do list.
Yes.
But all of the other apps, like people will say in all these groups, like I have this app and this app that, but they all pull data from the exact same sources. So of course they're all going to be KP based because that's what they're pulling from. The only the really the only one that's doing something different is the Glendale app, and then our friends at Aurorasaurus, which is trying to push the science further as well, which is why they keep looking for people to make um reports.
Reports.
Because
All the reports.
if you make reports, it helps them with algorithms to help these other models, like specifically the ovation model. The ovation model is kind of solar wind derived, so it misses substorms too. But if we keep getting data to these scientists so that way they can, give more to the computer algorithms, the better it's going to be. So Aurorasaurus and Andy at Glendale are definitely pushing this further. Um, we really are at the level where terrestrial weather forecasting was in the 1960s, if you want to put this in a perspective. That's how little we have to work with right now, and how we're on the precipice of something much bigger. It's going to take, I mean, obviously, look at between 1960 and now with the weather forecasting, just how much better it got over the span of what, 30 years. As we get more data to feed into the computers, we get more satellites and things to watch stuff, the better this is going to be. But for the time being, this is what we have to work with. Um, I just have to bring this stuff up because I've been kind of lectured about it a little bit. And I thought of and Tamitha gave me this really great analogy, but it's like, how would you like a tornado warning 3 hours too late? Because that's what the
Totally
K
appreciate that.
because that's what the KP index is. It's 3 hours in the past. And I thought that was a really great analogy to the whole thing and kind of the challenges that we're faced with and why we have this podcast, even though we have a lot of fun doing it, but it's also to help other people watching that, we still have a lot of work to do. There's things out there that make chasing a little bit easier now than it was even 2, 3 years ago. And to just kind of take this one little nugget that sure the whole industry uses it, but that's because they have to answer to operations. And I think I have that up in here too. Yeah, like you see in here that they need to alert industries like aviation, power grid operators, satellite operators, first responders, think they're critical to communications, not Aurora at all. So that is where their focus is. Us Aurora chasers, we're kind of on our own in a way. We have these data products. We just have to learn how to use them and use them in a better, more savvy way for Aurora chasing. But that is why it's there and why it seems like it's so standardized across the board. It's because they have to answer to different stakeholders. We don't. So we can kind of take this data and run with it, do whatever we want. We get cool people like Andy that's making Glendale. Um, Maybe I'll stop sharing so I can just do the whole thing. So you're not staring at a Word document anymore. Um, and that's our little stint on the KP, but it's there. We do know it's like the big elephant in the room. We wanted to discuss it because I figured it was a good baseline to jump off of for all the other things we want to do, like with going over the different apps. Because there's a few of them out there that are decent. for various different reasons. So that's kind of where we're gonna go. I think next week though, because we had an interesting thing come up, is we want to discuss photography and Aurora and how some people get bent out of shape when the snow turns green in a photo, and they claim that that never happens ever, even though they lived in Fairbanks for 3 years. Maybe if they were substorm tracking, they might have saw the snow turn green. I don't know, just a thought.
The usual visual versus camera debate, and then
So
just basic physics versus not having the knowledge debate. I
yeah, so I think that's where we're gonna go with it next week. We're gonna start the photography thing, and then we're gonna go into the going over different apps because I think that's important, kind of the springboard off of this KP discussion. Because a lot of the apps do use KP. So we need to discuss that and kind of dissect what apps do what well and others have limitations. And obviously we have a favorite because we mention it every week. But other ones have different things about them that are nice to have. And if you have all of them, then you just got a whole slew of things to go off of. So the more the merrier.
And really, yeah, it's not about picking a favorite necessarily. It's about using what tools you have for what purposes they're meant for. And going with the KP, at least for the people that have seen the alerts come out that NOAA puts, general warning, K7 index reach, da da da. If you read that whole thing, you'll notice that it gets very specific in most of the areas, except for the Aurora part at the very bottom, which is very general and vague. Geomagnetic activity causes a whole slew of other effects. Aurora is just a side product of that. There's no reason for really people to be notified about Aurora because it doesn't have any real effect as far as money is concerned. But power grids, radios, all of that, it's more important for all of that to be working, or at least for the issues to be known. So
Yes.
the idea is use all the tools you have, read all of the alerts that come out. We'll stop saying the KP is terrible. It just is not the best tool you could be using, or even close to the best tool you could be using.
Yeah. So there's my I'm going to humble myself a little bit. Like, it's fine.
Took a lot of guts for both of us to get through.
Because like I get it. I get why people use it. I do. And I know like sure some people thought maybe it comes across like being a know-it-all or things like that. And trust me, I'm as the furthest person away from being a know-it-all with all this stuff, but it's just our whole goal is just to try to get people to see Aurora and not be like this person that claims that I never saw the snow turn green. Okay,
Well, then
well
you really
maybe
haven't seen the Aurora that well then,
then maybe we can help you see that. That's
because it's
that's
real.
yeah, because it does happen. I've seen it several times, and I don't live in Fairbanks. I've been up there 3 times, and I've seen it every time that I've been up there.
Yep.
So it's like if you have the knowledge of these tools and then learn how to use it in a meaningful way, then you can see these things that other people see that you're like, no, that can't be real because I've never seen it. That's our whole point. So bringing it back full circle. I apologize if we've ever come across as know-it-alls or anything of that nature. It wasn't meant to be that way. I don't really want to harp on the KP being the worst thing ever because it is there. It has a purpose. It's just for what we want to do with it. It's not the greatest tool, like Christian said. There's better things out there. And that's our little discussion of KP today.
So if you have a nail, why are you using the back of a screwdriver to hammer it in instead of a hammer? That's all
Yes,
I'm saying.
exactly. It's like it this is why it's there. It's there for operations, really. It's there for climatology. And it does great at that. It does great at especially the climatology. Because you can just look back in any decade and get like a whole snapshot of geomagnetic activity for the entire year. And you can see where big storms happened. And especially if you're a researcher that wants to go back in time and like, hey, something happened on this day, you can find that. You can find it really easily. So it's great for climatology. And yeah, that's where I'm gonna leave it. So hey,
That was our rant. That was more constructive than
was
any
it?
rant before it.
Okay. Well, I will say if any of you have any questions at all, feel free to leave them in the chat or in the comments or even on Facebook or reach out. We're always here, so don't be afraid to ask any sort of questions. There's no stupid questions, trust me. It's fine.
And that's coming from, well, you said you started with the KP. I also started with the KP.
Yeah,
I'm sure you've missed shows from the KP, as have I. So, like,
yeah,
literally the bottom of the bottom of missing Aurora shows because of that data.
yeah. Like I've seen way more really good Aurora just switching, even just switching to the AE index.
Yep.
Like not even getting into the magnetometer stuff. If you just go over to the AE index, like if you want to like baby step your into, or even the HP 30 to some, baby step your way away from this 3 hour delay thing because that is a problem.
Killer.
So anyway, I hope we got something out of this, at least a little history on what the index is and why it's there. That was our whole point. So hopefully we'll see you next week when we talk photography. So it'll be a little different, it should be a fun one too.
And maybe
So
we'll have some activity to report. I don't know.
yeah,
That's
maybe
that's the hope.
something a little more exciting. So on that note, I'll end it for the